presenting on the determination of acidity in fruit juice. So acidity is one of the most important characteristics of fruit juice because it influences the taste, quality, freshness and shelf life of the product. So fruit juice naturally contain organic acid such as citric acid, malic acid and tartaric acid. This acid give fruit their sour taste and help prevent the growth of certain microorganisms. Measuring the acidity of fruit juice is very important in food and beverage industry. Manufacturers need to ensure their products have a consistent taste and meet a quality standard. By determining the acidity level, producers' quality can improve the consumer satisfaction. And one of the most common methods used to determine acidity in acid-base titration. In this method, a standard sodium hydroxide solution is added to the fruit juice until the acid is completely neutralized. The volume of sodium hydroxide used allows us to calculate the acidity of the fruit juice. So in this presentation, I will explain the principle of acidity determination, the titration process and its importance in industrial application. Thank you.
So now I will explain about the theory behind the determination of acidity in commercial fruit juices. So commercial fruit juices naturally contain several organic acid, with the most common is citric acid, malic acid and tartaric acid. These acids are responsible for the sour taste of the juice, which also will affect its quality, freshness and shelf life. So to determine the acidity, we use an acid-base titration. In this experiment, the fruit juice which acts as the acid is titrated with a standard sodium hydroxide NaOH solution, which is the base. By measuring the amount of NaOH needed, we can calculate the acidity of the fruit juice. So the neutralization reaction can be summarized as acid plus base becomes salt plus water. So to identify when the reaction is complete, we use phenolphthalein as an indicator. Phenolphthalein is colorless in acidic solution. They changes to a faint pink color when the endpoint is reached. This faint pink color indicates that all the acid in the fruit juice has been neutralized by the sodium hydroxide.
Okay, next I will explain the methodology used in this experiment. So we have the apparatus and the chemical reagent. For the apparatus, we use 50 ml burette stand and clamp. Next, we use 10 ml volumetric pipette with a pipette filler. Next, we have a 250 conical flask, a beaker, a funnel and a watt tile. These apparatus were used to carry out the acid-base titration accurately. Okay, next, for the chemical reagent, we use a commercial juice sample as the analyte, the standard sodium hydroxide solution as the titrant, phenolphthalein for the indicator to detect the endpoint, and distilled water to rinse the dilution. These materials and reagents allow us to determine the acidity or vitamin C content of the juice accurately through the titration process. Okay, next I will explain about titration procedure. So first thing first, we need to rinse the burette with standard sodium hydroxide, or we know as NaOH solution, and fill it with the same solution. And next, we need to measure pipette 10 ml of the commercial fruit juice into a clean conical flask, and we need to add 2 or 3 drops of phenolphthalein as an indicator and place the flask on a watt tile beneath the burette. And after that, we need to slowly add NaOH while continuously swirling the flask. Continue until a faint pink color appears and remain for about 30 seconds. And record the final burette reading and calculate the volume of NaOH that we use. And then we need to repeat until concordant results are obtained. And finally, we need to use the average titration value to determine the acidity of the fruit juice.
Moving on to our sources of error, which are especially important to consider when analyzing complex liquid like commercial fruit juice. First, we have human error during titration. Adding the sodium hydroxide too quickly or failing to swirl the flask properly can easily cause us to overshoot the endpoint. Second is parallax error. If the burette or pipette isn't read exactly at eye level, the recorded volume will be slightly distorted. Third is the indicator endpoint. Spotting the exact color change is subjective, and it may even harder because the natural color of the fruit juice can mask the indicator. Finally, there's the inherent inaccuracy of a measuring apparatus, as every tool has manufacturer calibration limits. Accounting for these variables is exactly why we run multiple trials to ensure our acidity data is as reliable as possible.
Next, I will explain the results of our experiment. Based on the table, pineapple juice recorded the highest titratable acidity, which is 0.86% citric acid, while mango juice recorded the lowest acidity at 0.25% citric acid. This result indicate variation of acidity among different fruit juices. Pineapple naturally contains a higher concentration of acids than mango, so it requires more sodium hydroxide during titration process. Several factors can also affect the acidity of fruit juice. This includes the type of fruit used, the natural organic acid composition, the ripeness of the fruit, and also processing and storage conditions. Overall, the experiment shows that the acid-base titration is an effective method for determining and comparing the acidity levels of different fruit juices. I will explain the industrial application of this experiment. In the food and beverage industry, determining the acidity of fruit juices is important because it helps maintain the desired taste and flavor of the fruit juices. It also ensures that the product meet quality and food safety requirements. Acid-based titration is commonly used as quality control method. It measures the citric acid content in fruit juice and helps detect any changes in acidity during the production process. Lastly, regular acidity testing helps maintain consistent acidity level in every batch of fruit juices. It also ensures that the product follows food industry standards and regulations. As a result, consumers receive a product with same quality, making it more reliable and increasing customer satisfaction.
To conclude, this experiment has shown that acid-base titration is a simple and reliable method for determining the acidity of fruit juice. By using a standard sodium hydroxide solution, an indicator, we can accurately measure the amount of acid present in the sample. Knowing the acidity of fruit juice is very important because it affects the taste, quality, freshness, and shelf life of the product. These manufacturers maintain consistent product quality and ensure that the juice is safe for consumer. In industrial application, acidity analysis is widely used in the food and beverage industry for quality control, product development, and meeting food safety standards. And regular testing also helps companies improve a customer satisfaction by producing a product with consistent flavor and quality. Overall, acid-base titration is an essential analytical technique that provides accurate results and play an important role in both lab, experiment, and food industry. That's all from me. Assalamualaikum.